So as Keith says, I'm very conscious that I'm stood between you guys and beer, so I'll try and keep this as brief as possible, but there's quite a lot of information I want to try and get over. I thought this was a great picture as an initial demonstration of when major electrics go wrong. This was the New York City skyline just a few weeks ago. One of their major electrical high voltage substations had a failure. It started arcing and lit up the whole of the sky. So when we're talking about big electrics, we have to be pretty careful. So I'm Steve Wright. I'm one of the directors at 4D Data Centers. I also sit on the board of LINX and a couple of other data center and hosting companies. This presentation came around after having a discussion with a number of people in the industry talking about an unfortunate thing that happened to us in our Byfleet facility where we had an accidental release of FM200. Very costly, about £50,000 costly. But it's one of those things which actually, I want to open up a bit of this taboo about people not talking about issues that have happened in their data centers. And I've got to thank a whole variety of people for providing input. Most of them have been anonymous and wanting to ensure that we don't call out individual data center operators. But without that, I wouldn't be able to put this presentation together. So over the last 15 to 20 years, I've built up a whole variety of facilities, everything from the cheap and cheerful in the early 2000s, where you could get away with not putting in much resilience, question whether you needed fire suppression, and if your website or email went down, customers wouldn't care for a few days. They'll be like, that's fine. Nowadays, obviously, that's a very different environment. The level of investment we see into data centers is quite significant. Just a brief word on 4D, seen as that's one of my companies. We've got facilities in Byfleet, in Sussex, and Gatwick Airport, just in Crawley, on the Manor Royal Estate. So if you need any facilities, please give us a call. So I wanted to start with a bit of a hands up. Who here has seen their fire suppression system in a data center or POP? Yeah, those little red bombs you might see around the room. Right, keep your hand up. Have you ever had the fire alarm go off while you've been in the data center? And have you evacuated the data floor? Or have you stayed in the room because you thought it was a false alarm? And those final few people, have you been in the room when the suppression went off? So you definitely get some beer because it's not the greatest environment, is it, to be in? So I think that's just sort of a representation. If we look at this room of 180 people or so, I think we've got 3 people who've been in a room when a fire suppression system went off. It is relatively rare. So ultimately, we're trying to stop this. When your NMS reports a temperature issue, you think, oh no, Telehouse have got an aircon problem or the such. Or your equipment could be turning into a charred, gooey ball of mass. This was a fire in a Brazilian data center last year. I've not been able to verify whether they had any fire suppression in the facility or where the fire started. But this is really unusual. And from all the discussions I've had with people, I've yet to hear of a fire in a data center actually starting in the data hall. So if you've got any experience of that, please let me know. Speaking with a whole load of fire suppression specialists, actually, it's very rare for them to see this. What they do see, UPS rooms, electrical switchgear, and batteries, that's the main source. And then that leads to the actual facility catching alight and going into a larger situation. So, a very brief overview. Just want to cover off these main points to give you a bit of background and how we get into fire suppression systems, and then some of our experiences and some of the input I've had about when it's gone wrong at the end, which is obviously the more interesting part. So, the fire basics. We all remember the fire triangle from school, right? You need those 3 key things: bit of oxygen, bit of heat, bit of fuel, and you've got a fire. When we look at fire suppression systems, we actually need to modify that slightly. And we add the fire tetrahedron. And we add the chain reaction piece at the bottom. So you can only actually cause a fire through the chain reaction and those 3 elements working together. If you remove that, you don't have a fire. And we'll come back to that in a bit shortly. Fire detection. We spend loads of time in this industry looking at monitoring systems and trying to find granular bits of information. And it's the same when you're a facility operator. You want to know when something's happening actually inside your building. We've got 3 main types. We've got the aspirating systems. You'll hear them referred to as VESDA or IFDs. we've got your traditional smoke detectors, optical and ionizing, and then your heat detectors. If you've got that much heat in your data center, it's probably a bit too late. Probably most of you know this already, but an optical detector just has a photoelectric LED and a receiver. It doesn't actually work by the process of that light shining onto the photoelectric receiver. It's actually when smoke particles come and interrupt it, and then light is reflected. So it's not a constant beam on, but a refraction element. With ionization, you've got a radioactive source, and through the alpha rays, you've got positively charged ions and negatively charged ions being received by plates. And when smoke particles get involved there, they actually neutralize that process, and that causes the interruption. Once again, with these two types of detector, you're probably in quite a serious stage fire in terms of a data center facility if you're using these as your detection points. However, the aspirating systems, VESDA, very early smoke detection apparatus, they're anywhere between 500 and 1,000 times more sensitive than the traditional optical and ionizing smoke detectors. This gives you your reaction time. So the way an aspirating system works, you'll see probably red tubing around the data floor, maybe over air conditioning and downflow units. That's constantly sniffing in the air. It goes through a very sensitive laser, and that detects the early stages of combustion and can give you warnings at various stages. And on that point, so we get this pre-alarm process, and as a fire develops in the incipient stage, this is where your VESDA is worthwhile investment. It actually gives you that very early warning to be able to react and have your teams, however you train them, respond to the incident. As a data center operator, our VESDA goes off a number of times throughout the year, primarily server PSUs, the magic smoke coming out the back. It alerts us. The teams get onto the data floor and go around, do some sniffing, and actually generally you'll find a tripped breaker or such. But as you can see, we move along into visible smoke. That's when those smoke detectors, ionizing and optical, start detecting, and that's where we get into our NOx situations. And I'll come on to that in a little bit more detail in a moment. So when we talk about fire suppression, we've got three main types. Water, everyone's familiar with that. Oxygen reduction and chemical interaction. I always refer to these as the little red bombs in a data center, purely because you've got super high pressure in these cylinders, weighing anywhere between 150 and 200 kilos, and anywhere between 150 bar and 300 bar. If they're not well secured, they'll cause issues in your facility. And I'll show you some pictures of when it's gone wrong later. So, water suppression. We've all seen sprinkler systems, and in reality, there's not a lot of deployment inside data centers for protecting the technical equipment. You'll primarily see it for protecting the building. And a lot of the large-scale wholesale providers will actually just invest in a water or high fog-based system now. I don't have much personal experience in deploying these types of systems because I run a multi-tenant colo facility, and I'm still not 100% sure about lots of water around all my electrical equipment. Just one of those superstitious things. On the oxygen reduction side, you'll have heard of two types, argonite and inogen. Both of the same principle, reduce the oxygen level below 12.5%. And that is the point at which combustion should no longer occur. Apparently, if you're in the room, it feels a bit like being at Everest Base Camp, but if you're perfectly healthy, you should be okay to carry on operating in there, or at least run out the room. One of the big things about this is obviously it's displacing a lot of the air in the room. So you need to make sure there's proper vents to relieve that pressure as it gets deployed into the room. And then finally, chemical-based suppression. So pretty familiar with FM200 and UKNOF42. They're certainly the most commonly deployed over the last 15 years. And these chemical-based suppressions actually interfere with that chain reaction element of the fire tetrahedron. That's why we had to do that little precursor a minute ago. Now, we say no halon. No new halon system should have been installed in the past 20 years or so. But they can still be installed using recycled halon. The reason they've been taken out is because it really upsets polar bears. they're really bad for the environment. So it's one of those conscious things as part of the Kyoto Treaty, if I remember correctly, that we shouldn't be producing these gases anymore. One of the misnomers about halon is that it will kill you. Actually, it doesn't. It's still the most effective fire suppressant in the world. No matter what we have with FM200 and Novec and other gases that are being developed, halon, you only need about 5% concentration in a room for it to interrupt that chemical and chain reaction. So ultimately, not great if you want to do big installs, but effective on aircraft and certain other military uses as well. So we put all of this together. We've got our detection, and as I say, we've got the VESDA pre-alarm. That's that very early incipient stage. And actually that should start alerting maybe a facilities team to go and investigate. When you get to VESDA fire, something more serious is happening. That is likely that you've got something starting to smoulder or an ignition source starting to take hold. The first and second knocks, that's generally controlled by your ionizing or photoelectric detectors. And at first knock, okay, you're thinking there's some serious issue in the facility. At second knock, you're going, oh crap, we've got some major issues here. And generally, that second knock, or a double knock, you may have heard it referred to, is the point at which your fire suppression system will be brought alive and it will start its countdown to discharge. And that countdown is anywhere between 30 and 60 seconds, depending on the configuration of the system. Really, at that point, you should have no one in the room, shouldn't be present. It's best that you're out of the room. And then, ultimately, sad face if it's not a real fire, because it's just cost you a hell of a lot of money, anywhere between 3,000 and 5,000 a cylinder. And for a 10,000 square foot data center, you're talking between 12 and 15 cylinders. So when I was putting this presentation together, one of the things that was fresh in my mind was having an FM200 discharge. So I posted it on LinkedIn and said, hey, let me know of your experiences. And every single time, it was a chain reaction of events that led to the accidental discharge. There was either a procedural failing or some other failure rather than a fire that generally led to the system discharging on a data floor. So, telling you a little bit about my experience. In July last year, we had one of the firing mechanisms on a single cylinder of FM200 fail. That caused 120 kilos of FM200 fire suppressant to be discharged into the data center. Okay, a bit painful on the wallet, but not the end of the world. However, that discharge from a nozzle just like that hit 2 detector heads as well, which then armed the whole system. So we'd gone from a fault situation, which seemed okay, to a full system readiness in about 3 seconds. And from time of the failure of that seal, we had 63 seconds to be able to make a decision as to what was going on in the facility, whether we should hold off, whether there's a real fire, and how do we handle that. Ultimately, we had to make the decision to leave it. We can't judge whether, under that stressful situation, what was happening there. So that, I would class as a bit of a design flaw from our standpoint. But speaking around the industry, it's a 1 in a million failure chance from FIKE on that electromechanical release of that cylinder. So it's pretty unlikely. Some of the other side effects. So someone sent me a couple of pictures of their Inogen system releasing. One of the unexpected side effects, all the pipes froze. Now, that's okay if it's outside your data hall. However, your pipes are going all the way through your data center, above all your ceiling tiles, above all of your racks. Fine in the first 5 minutes. Get to minute 10, while your equipment's warming those pipes back up, you've now got dripping water over your equipment. Pretty unexpected, and not one of the design features, certainly for that company. Aircon. So we've moved to trying to use fresh air systems, being a bit more environmentally friendly. For either an oxygen reduction system or a chemical-based system, you need to fully seal the room. And if you're running a fresh air system, that means you've got to turn your external airflow an input into the room off for 15 minutes. That can play havoc with your temperatures. So you might have had an accidental release, thought, okay, all my equipment stayed online. 15 minutes later, you've got a data center that's 10, 15, 20 degrees hotter than it was before, and you start experiencing equipment failures. That's one of these unexpected side effects that we see. The classic for too much noise. So a number of years ago, someone produced a YouTube video of don't shout at your SAN, it makes it unhappy. And what happens if you shout at your SAN, your disk latency goes through the roof. Now, with a couple of the oxygen reduction systems, due to the volume of air coming out of the nozzles, this creates a 130 decibel pressure wave through your facility. The most notable instance of this was ING Bank in Romania. It took them offline for 48 hours as it trashed all of their SANs. Tyco then had to do some work and investigate what are the upper limits for hard drives, and it turns out 110 decibels is about okay, but then subsequently designed a special acoustic nozzle for use in data centers that made it a bit quieter. So one of those interesting questions to ask your data center operators. My good friend Barry Wright. So I went into the room after the FM200 discharge. One of my unexpected side effects, when I came out, I had a really deep voice. And I wasn't sure who was speaking. I literally came out and was like, nope, there isn't a fire. Who said that? Now, in hindsight, it's pretty obvious, quite a heavy gas, the opposite of helium. So it's one of those fun things. Probably don't want to try it too often, though. As I mentioned, we're dealing with some high-pressure systems. Now, the pipework has to be bolted pretty firmly to the structure. As you can see, mountings can rip out of ceilings and walls, and the pipework can twist and bend. So this is just one of those other little considerations that you'll have issues should you experience a discharge. The mechanical installation is very, very critical. And this brings me on to probably the worst incident in the UK that I've heard of. So this was a refurb of a private data center that was happening in Welwyn Garden City. Now, here we can see them installing a new Argonite system. Unfortunately, they're breaking lots of safety protocols. So it's hard to see, but none of those cylinders are strapped to that framework. And on the floor, you can see the little silver caps. Those are special safety valves that are screwed on to these cylinders, so that if there is an issue with the valve on top, it will release at about 10 bar, as opposed to 300 bar. This had a fatal effect. So there was an electrician who actually died in this incident. So one cylinder fell over, sheared its top valve, crashed into the other cylinders, and that was the outcome for that room. However, the rooms next door to it also experienced a few issues. So these are systems that you have to make sure you're confident in them. Make sure your mechanical install is very, very good, and you've got trust in the people installing them. As I say, there was a chap who died in this incident. 2 other people were pretty seriously injured with life-changing condition, and at least 6 other people, I think, ended up in hospital as an outcome of this. So one of those things which you have to take seriously. For the companies involved in that install, there was about £1 million of fines issued by the Health and Safety Executive. So when it goes wrong, it really does go wrong. Finally, some of the improvements piece. So no matter how much we're training people, in my own business, speaking with other data center operators since our experience, one of the things we've found is, it's classic, expect the unexpected. We do it a lot for a lot of different systems and processes, but actually we thought with our fire suppression system would have that nice staged process, a nice VESDA pre-alarm, right? Like a VESDA fire, smoke detector 1, smoke detector 2, system discharge. Because we got to that system discharge in 3 seconds, it was unrealistic for us to expect one of our employees to be able to assess whether there was a real fire and, as I say, press any hold-off buttons. So from that, it's made us reevaluate the whole of the system and look at, as I mentioned, that chain reaction piece. Was it a design flaw? Was it a failure in our process? Was it a failure in our training? On that, we found that actually our team weren't being trained enough. I'll be the first to admit we were doing it once every 6 months. Actually, having a rolling program every 12 weeks to make sure you're covering every single employee in your technical team, if you're operating a data center, is pretty critical for this. And it's not just for your fire suppression system. Think about your electrical systems, generator failed starts, UPS bypassing, all of the elements which are critical to maintaining infrastructure and seem like the basics, but being really good at the basics makes sure we can carry on operating networks and systems. I'd be interested in hearing other people's thoughts on what they've changed, or if they would change anything, or what they're doing at the moment. It's one of the challenges, as I say, this is a bit of a taboo subject where people don't like to talk about failures and issues. But if we look at other mature industries, airlines, medical, they have an acceptance that things do go wrong. Actually, within the data center industry, it seems to be a bit either embarrassing or worried about what your competitors are going to think, or just a personal embarrassment. I don't think that's the right attitude to bring to this. So if you do have any stories, I'll happily take them. I'll anonymize them. And I'm sort of working with a few other organizations now to try and bring this to the fore and maybe do updates out to industry surrounding it. So ultimately, that big question, is fire suppression worth it? Now, that's a big question only you guys can answer when you're putting equipment into a facility. For the majority of our customers, it's like a hygiene factor, just a tick in a box to say, right, that's good enough, we're happy with that. But based on the probabilities of accidental releases, damage to potentially equipment or life, it's one of those things that is a very hard balance to create. It's a bit like an insurance policy. You hope you never have to use it, and it's unlikely you will, but everyone likes to have it there just in case. So, any questions? Well, that was a whistle-stop tour, so.
Okay, Thomas.
Thank you very much for the presentation. Thomas from Flex Optics. Is there a certain stage where you automatically shut down the power in your data center then?
The design of the clean agent, the chemical suppression and oxygen reduction systems, are designed that you continue operations throughout. So I've heard of people having an accidental discharge. Generally, your firearm's going to be integrated to the fire brigade arriving at a site and then saying you need to shut off power before we go into the building. With the water and high fog-based systems, supposedly you can carry on operating. Once again, I've always been taught electrics and water don't mix so well. But certainly with the chemical, the clean agents, so oxygen reduction and chemical, you should be able to continue operating as you were.
Thank you.
Okay, any other questions for Steve?
Cool.
Okay, thank you very much, Steve.
Cheers, guys.